Hi, welcome to my channel. In the previous video, we discussed about the definition of decision tree, and the types of decision tree algorithms like ID3 algorithm, C4.5 algorithm, and CART algorithm. And also we discussed about the how to train the decision tree algorithm and how to visualize the decision tree. Decision tree. And also we are going to estimate the class probabilities, estimation of class probabilities for the given data points, and also we are making the prediction for the class label for the given data points. And also we discussed about the how to construct the decision tree with the help of CART algorithm. It internally uses the concept of Gini index value, and also the how to construct the decision with the help of ID3 algorithm. ID3 algorithm internally uses the concept of entropy. Entropy. Now we see and also we discussed about the how to construct the decision tree with the help of any algorithm like a CART algorithm or ID3 algorithm. It internally uses the different types of hyperparameters. Here the Sklearn tree provides some class label that is called as a decision tree classifier. It internally provides some hyperparameters. So by changing the values of hyperparameters, we can get the better construction of the decision tree. So here the default value we are going to construct the decision tree is the Gini value. That means we are going to use the concept of CART algorithm. Suppose you want to construct the decision tree with the help of ID3 algorithm. So here we are going to change the value of the default value of criterion. We have to change as a entropy. So internally it uses concept of entropy, and we are going to construct the decision tree with the help of ID3. So like that we are going to construct the decision tree. Now we are going to see the next topic is regularization of hyperparameters. So what the importance of regularization of hyperparameters? So in order to overcome the overfitting, simply we are changing the values of these hyperparameters. So we will discuss that one here. Now the regularization of hyperparameters, decision tree mainly uses the different assumptions are there on the training data. So as it is a decision tree make very few assumptions are about the training data, as opposite to the linear models which assume that the data is linear. That is here we are having the two types of models are there. One is a non-parametric model and the second one is a parametric model. Now the non-parametric model is the tree structure will adapt itself to the training data, fitting it very closely indeed and most likely to overfitting it. Simply this process is called as a non-parametric model. So such a model is called as a non-parametric model. Now not because of it does not have any parameters. It often has a lot of parameters are there. Even though it does not become any parameters. So, but because the number of parameters is not determined prior to the training, so the model structure is free to stick closely to the data. So that's why this model is called as a non-parametric model. So coming to a parametric model, so a parametric model is a linear model, has a predetermined number of parameters are there. So its degree of freedom is limited, reducing the risk of overfitting but increasing the risk of underfitting. So here there is a concept, there is a possibility of overfitting is there, but there is no there is a difference between the parametric and non-parametric things. Now to avoid the overfitting and of the training data, you need to restrict the decision tree freedom during the training. This is called as a regularization. So you can change the hyperparameters of the model. You can restrict the overfitting, the concept of the overfitting. Okay, so simply that process is called as a regularization. The regularization of hyperparameters depends on the algorithms used, and but generally we can say at least restrict the minimum depth, maximum depth of the decision tree. So here there is a concept called as that is called as a maximum depth. Okay, we can restrict the maximum depth of the tree automatically. That gives the that minimize the concept of overfitting. Okay. Now here in the Sklearn, this is controlled by the max depth hyperparameter. So in the Sklearn of the decision tree classifier provides the some different hyperparameters are there. Okay, and the decision tree classifier, okay, it contains different hyperparameters are there. So the max depth is the main control of the hyperparameters. Okay, the default value is none. Okay, which is means unlimited. The reducing the max depth will regularize the model and thus reduce the risk of overfitting. So here see the decision tree classifier that is provided by the class Sklearn.tree decision tree classifier. So here the star mark is there, that is default value, and criteria equal to Gini value. That is the default value is Gini value. That means you are using the concept of CART algorithm. Suppose you want to change the if you want to implement the ID3 algorithm, just to change the value of criterion equal to entropy, then automatically it implements the concept of ID3 algorithm. Then splitter equal to best and max depth equal to none. This is the very important hyperparameter. The default value equal to none. That means it goes into, you can construct the decision tree with max depth. Okay, max depth. Okay, there is a possibility of overfitting. Each and every point become a one class label. So in order to work on that point, you have to minimize you have to restrict the max depth. That is, we can provide the values 2 or 3 like that. Okay, so we can cut down the maximum depth of the tree so that we can minimize we can reduce the overfitting concept. Then there are different other parameters are there. Min underscore samples underscore split equal to min underscore samples underscore leaf equal to 1, min underscore weight underscore fraction underscore leaf equal to 0.0, max features equal to none, random state equal to none, max underscore leaf underscore nodes equal to none, min underscore impurity underscore decrease equal to 0.0, class weight equal to none, CCP underscore alpha equal to 0.0, and monotonic underscore CST equal to, like that we are having different hyperparameters are there. We can change the values of the different parameters. We can restrict the concept of the overfitting. Okay, now the decision tree classifier class has a fewer other parameters that similarly restrict the shape of the decision tree. Okay, like max depth. Now minimum samples split, that minimum number of samples a node must have before it can be split. That is the main. Okay, that is the very required. Okay, min underscore samples and split. The next one is min underscore samples underscore leaf. The minimum number of samples a leaf node must have, and minimum underscore weight underscore fraction underscore leaf, same as the minimum underscore samples underscore leaf, but expressed as a fraction of a total number of weighted instances. And max underscore leaf underscore nodes, the maximum number of leaf nodes, and max underscore features, the maximum number of features that are evaluated for the splitting at each node. So like that we are increasing the minimum hyperparameters or reducing the max hyperparameters will regularize the model. So other algorithms work by first training the decision tree without any restrictions, then pruning the unnecessary nodes or deleting the unnecessary nodes. A node whose children are all leaf nodes is considered unnecessary if the purity improvement it provides is not statistically significant. So standard statistical tests such as size code test are used to estimate the probability that the improvement is purely the result of the chance, which is called as a null hypothesis. If this probability called the p-value is higher than the given threshold value, typically this is 5% controlled by the hyperparameters, then the node is considered as unnecessary and its children are deleted. Like that we are going to delete the unnecessary nodes. Then the pruning continues until all the unnecessary nodes have been pruned. Okay, so here we see the one decision tree construction with the help of without no restrictions with some restrictions. Okay, so this is trained on the some data set that is called as a Moon's data set. On the left side of this data set, that decision tree is trained with the help of default hyperparameters. There is no restrictions here. On the right side is the train with the minimum samples leaf node is 4. Here this is a minimum samples equal 4, and here without no restrictions. Okay, so now it is quite obvious that the model on the left is overfitting and the model on the right will be probably regularized the better. So here see the difference here. It gives them it meets and the model exactly provides the it is a overfitting. It classifies each and every point becoming one class level. Okay, it is a overfitting here. Okay, but whereas coming to this hyperparameter tuning, that means we are applying the regularization concept. So here we are setting the minimum samples leaf node contains equal to 4. Then it automatically divide the data into without any overfitting. The model is constructed decently. Okay, so like that we are going to overcome the concept of the overfitting. Okay, with the help of regularization of hyperparameters. Simply this is called as a regularization of hyperparameters. That means there are a lot of parameters are there in the corresponding class label, that is called as a decision tree classifier. In order to avoid the overfitting, you must regularize you must change the values of some parameters, so that our model, our decision tree model or decision tree classifier exactly classify the data into multiple parts, multiple corresponding class labels. So this is about the regularization of hyperparameters. In the next class, I am going to discuss about the regression. That means the decision tree is worked as a classifier as well as a regression purpose also. In the next class, I am going to explain about the decision tree regression. Thank you for watching our video. If you like the video, please subscribe my channel. Thank you.